Hey, what's going on, guys? Let's do this problem right here. The question is asking find the work and the heat energy, change in internal energy, and this initial pressure, final pressure. Let's see how we can do this. So first of all, in an isothermic process, delta U is equal to 0. If you want to know why, if you apply delta U is equal to NC delta T, you know that in an isothermic process, final and initial pressure is going to be same, so delta T is going to be 0. So that makes everything 0. So that's how we derive delta G is equal to 0. And if delta G is equal to 0, according to first law of thermodynamics, we know that delta G is equal to Q minus W. If delta G is equal to 0, Q is going to be equal to W, right? Because Q minus W, this is equal to, therefore Q is equal to W. So if we find Q or W, one of them, if you find one of them, that's going to answer the other one, right? In the isothermal process, to find the work, we use this formula. W is equal to nRT ln V final over V initial, right? So this is the equation. Whenever we have isothermal, we use this. If you want to know why, there's a reason behind it. Like, this is not, if you look at the isothermic graph, it always goes like this. It's not going to go straight line. So in this case, we can't find the area of this one, or we can't calculate work using P delta V, right? So here we have to use the calculus. So here, if you use W is equal to integral P dV, right? That's how we find it. So instead of P, we know that PV is equal to nRT. So P is equal to nRT divided by V, right? nRT divided by V. Then we substitute that this value instead of P. So that's going to give us W is equal to, going from V1 to V2, nRT divided by V dV. So except V, everything else is going to be constant. So here nRT is going to move to the front. It's a constant. So we are going to have V1, V2, 1 over V dV. So integral of 1 over V is going to be ln V. So nRT ln V going from V to V1 to V2, right? Then if you do the substitution, it's going to be nRT ln V2 minus ln V1. If you subtract logarithm, it's same as dividing each other, right? So nRT ln V2 over V1. So that's how we derive this equation. So let's go ahead and plug the values to calculate this answer. So first of all, we have the mole that's provided, 2 mole times R. R value is 8.31 joule per mole Kelvin. And then we have temperature. So for an isothermal, temperature is going to be same. So you can pick initial or final, all are going to be same. So here 500 Kelvin. 500 Kelvin times ln V final is 40 liter. 40 liter. V naught is 20 liter. We don't have to convert liter into meter cube because the liter and liter is going to cancel. So let's, if you calculate this one, that's going to give you 5764 joule. 64 joule. If this is 764 joule, we already proved it. Q is equal to W. Therefore, Q also going to be equal to 5764 joule. Now we have answered these 3 parts. Let's see how we can find the initial pressure. To find the initial pressure, let's see, we can use PV is equal to nRT, right? So to do that one, initial pressure, so P naught is going to be nRT divided by V. So to calculate in this one, we have to know whether everything is available. So right, we have the mole, we have R, and T. Do we have the initial temperature? Initial and final is going to be same, so we can apply 500 Kelvin. And then volume also we have, so we can go ahead and find it. So this is going to be 2 times 2 mole times R is going to be 8.31 joule per mole Kelvin times T is 500 Kelvin, and then V is going to be is 20 liter. Now we have to convert this one into meter cube because we have other sign SI unit, so we have to convert this one into SI unit too. So we know that 1 liter is equal to 1000 meter cube, right? I mean 1 meter cube is equal to 1000 liter. 1 meter cube is equal to 1000 liter. Therefore, this is to convert this one into meter cube. I have to divide this one by 1000. If I divide this one by 1000, that's going to give us 0.02 meter cube. And if you calculate this value, that's going to give you 415,750 Newton per meter square, same as Pascal, right? Newton per meter square, Pascal, same thing. Now we have this value, initial pressure, P0, right? To find the final pressure, if you look at the final volume, that is 4 times bigger than the initial. So the divide, when we divide, we are going to change only the final volume, that's 0.04, right? So it's going to be half of this amount. So the half of this is approximately 4 atm, right? So the final pressure is going to be half of this value. If you look at this one, it's almost like 416,000. So we can write as 208,000 Newton per meter square, and that's approximately 2 atm, right? And that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.